In the second half of this tutorial, we'll be focused on how we can use visual-acoustic biofeedback using LPC spectrums as part of treatment for misarticulation of R. So before we get there, there's a couple goals that I have for background information that I want to make sure that we have a good sense of. The first of those two goals is getting a familiarity with the general Formant signatures that are common to correct R and incorrect R. The second general goal is making sure that we already have a good understanding of the spectrogram, so let's get a good sense of exactly how the LPC spectrum compares and contrasts to what we know about the spectrogram. So I thought we could perhaps chip away at both goals by simply opening up an LPC spectrum on one half of the screen and opening up a real-time spectrogram on the other half of the screen, which I did just by going to CSL, going to the menu, and I clicked on Sona-Match for the LPC spectrum and real-time spectrogram. You'll see that I already recorded, it's a 35-second speech sample on the bottom here in the spectrogram. We have 5 different utterances. From left to right, I did correct R, incorrect R, the word red, the word rabbit, and a incorrect R, eventually making it to a correct R. So first I want to ask you a couple questions about the word red and the word rabbit. So again, I said, this is what correct R looks like. And this is what incorrect R looks like on a spectrogram. Based on that, what do we know about the R sounds that are in the beginning of the words red and rabbit? Do you think that that R is a correct R or an incorrect R? Yes, for both utterances, I'm sure that you were able to answer this correctly. For both utterances, they start with an incorrect R sound. So I did something like ooh. Here I said ooh-ed. Here I said ooh-abbit. And here in the last utterance, I said something like ooh. So let's just click around. From time to time, I'll do a recording on the LPC spectrum, and I'll do my best to mirror the way that I produce particular speech sounds here in the spectrogram. It won't be the exact same sound, but it'll be very similar. After all, I'm the same person. And we can see how we can compare and contrast the formants, where they are, and also the graphs themselves. What are we learning on one of the graphs? What are we seeing on the other graph? So let's go ahead and look at the first two. We have correct and incorrect R. Right off the bat, we notice a number of things just looking at the real-time spectrogram about the location or the lack of the location of particular formants. So because I generally have a good sense of where formants should be for correct R, I'll just go ahead and spoil it a little bit, but this faint horizontal band is indeed formant 1, and this very heavy thick band between 1000 and 2000 frequency is both formant 2 and formant 3. But don't take my word for it. I saved this same exact 35-second speech file as a WAV file. I opened it up in Pratt. Here we have the same 5 utterances. Let's go ahead and zoom in on the beginning of the first utterance. When I recorded this, there wasn't really an onset that was captured, so it's safe for me to go pretty close to the beginning. The onset proceeded when I clicked record. Okay, so looking at the beginning of this first correct R utterance, we can approximately see that the first formant is around 500, the second's 1450 or so, the third's around 1712, let's say. So I'm just going to jump ahead here. I already did approximately write down where the formant locations were for formants 1 through 3 of the correct R, I did the same, just following the same approach. For example, if I were to do this, I would zoom out, jump ahead to a place that I reasonably think is post-onset in the incorrect R, zoom in, and then I could just, I could just kind of click approximately, looks like 330, 690, 2680, wow. And then I wrote those numbers down here. Approximately is good enough. So, of course, there's a number of differences between one correct version of R and one incorrect version of R, but the key question here to keep in mind is what is the most important one or two defining differences? And I've circled them. The first is that the hallmark characteristic, I've written them down too. The hallmark characteristic, the single one, most important characteristic that's very noticeable of a correct R is number 1 right here. The F2 and F3 are going to be close together. They're only 250 hertz apart. Compared to this incorrect R, which is 2,000 hertz apart. So that's a very noticeable difference. And of course, we can notice that here. Formant 2, Formant 3, very close together. Formant 2, because remember it's Formant 1, Formant 2. Formant 3, very far apart. And the other thing worth noting, because it is pretty significant, is that the correct R, especially compared to an incorrect R, has a far lower, so we said these are closer, but most importantly, that's the F3 coming down to the F2. It's also F2 is higher than in most incorrect Rs, but that's a difference of 700 hertz. This is a difference of 1,000. So that F3 coming down is maybe the second most notable characteristic of the correct R as far as its formant signature. And, we're in the weeds, but let's take a step back. We can see it very clearly here. 1, 2 close together in incorrect R with 3 far higher. And here we have 1 and then 2 and 3 very close together with 3 far lower in frequency than 3 in the incorrect R.